Hello friends, welcome to Learner's Planet. Friends, this is our second session for polynomials. In our previous session, we have discussed about the basic terminologies related to polynomials and algebraic expressions and identities. We have already solved some problems based on the basic concepts of polynomials. In this session, we'll be taking such problems, more such problems in fact. So let's begin this session. Now friends, let's discuss how to write a polynomial in standard form. Okay, so when we wish to write a polynomial in standard form, we should begin with the term which is having the variable with highest exponent. Okay, so let's do the first example. It's 9x cubed, then plus 8x square, then plus x and minus 7. Do not forget to retain the sign of the term. Okay, here 7 is negative, so I put a negative sign over here. X is positive over here, so I put a positive sign before x. Okay, now similarly let's try this. The highest the term with highest exponent of variable is minus 3x cubed, then minus 5x square, then plus 4x and then plus 6. So highest power, then the second highest, third and the constant. Okay, similarly let's see over here the highest power of the variable is 4, so let's begin with 7x4, then plus 6x cube, then minus root 2x square, then minus x and then minus 4. Okay, so it's very simple. It's the highest power over here is 4, so let's begin with 9y raised to 4 plus 5y cube plus y square minus 7y minus 11. So this is the method to write a polynomial in standard form. Okay, I hope you are clear. Now let's discuss zeros or roots of a polynomial. Zeros or roots of a polynomial is a value of a variable at which polynomial, let's say px, becomes 0. Let's take in one example. If polynomial px is x cubed minus 6x square plus 11x minus 6. Suppose I put x is equal to 1, and if I get the value of this polynomial as 0, then 1 is a 0, or we can say the root of the polynomial. Let's put the value of x as 1. So p1 is equal to 1 cube minus 6 into 1 square plus 11 into 1 minus 6. So it's 1 minus 6 plus 11 minus 6, which is 0. So if I put x is equal to 1, I'm getting the value of this expression or the polynomial as 0. That means 1 is the root, or we can say 0 of this polynomial. Okay. Now 0 may be a 0 of a polynomial. Suppose I have a polynomial like x, x4 minus 5. Then in this case, suppose it is a polynomial px. So if I put x as 0, the value of this expression will be 0. Okay, that means 0 is 0 or root of this polynomial. Okay. Now every linear polynomial has at most one 0. Okay, that means it has to be there. Every polynomial is having zeros. Now if it is a linear polynomial, it will be having 1 0. Let's take one example. Now suppose I have a linear polynomial, maybe px is equal to x plus 5. Now if I put x is equal to minus 5, I'll be getting the value as 0. That means minus 5 is a 0 of this linear polynomial. Okay, why we call it a linear polynomial? Because the power of variable over here, or we can say exponent of variable over here, is just 1. Okay, so we'll be having just 1 0 for this polynomial, or we can say there is just one root for this polynomial. We cannot have more than one root if it is a linear polynomial. That means you cannot have any other value of x which will make this expression as 0 except minus 5. So you have only one choice, that is minus 5, by which this polynomial will be 0. Okay. So if it is a linear polynomial, you will have 1 0 only. Okay. Similarly, if it is a quadratic polynomial, it will be having at most 2 zeros or 2 roots. Let's take one example. Suppose I have a polynomial x square minus 4. Let's say px. Okay. Now it can be written as x plus 2 into x minus 2. Okay, so it's px. Now I'll be having just two values which will make this polynomial as 0. These are 2 and minus 2. So if I put 2, then this expression will be 0. So if this expression is multiplied by 0, the entire expression will be 0. So p2 is 0 and p minus 2 is also 0. Okay. No other values of x will be there which will make this expression as 0. That means every quadratic polynomial can have at most 2 zeros, and the quadratic polynomials can have both the zeros as same also. Okay, so in this case we are having 2 zeros, that is 2 and minus 2, or we can say we are having 2 roots as 2 and minus 2. Okay. We'll discuss the concept of roots in detail while solving the problems. Similarly, a cubic polynomial can have at most 3 zeros. Suppose I have a cubic polynomial px as x minus 1, x minus 2 and x minus 3. It's a cubic polynomial because after expansion we'll be getting the power of x. Highest power of x, I mean, is 3. Okay, so p1 is 0, p2 is 0 and p3 is 0. That means if I put the value of x as 1, 2 or 3, the value of this polynomial will be 0. No other value of x can make this polynomial as 0. Okay, so there are 3 and maximum 3 zeros of this polynomial, or we can say a cubic polynomial can have at most 3 zeros or 3 roots. Okay. Now let's discuss a remainder theorem. It states that if a polynomial px is divided by a linear polynomial qx, then the degree of the remainder must be 0. That means it has to be a constant, and this constant may be a 0. I take an example. 3x square plus x minus 1 can be written as x plus 1 into 3x minus 2 plus 1. Here this 1 is the remainder. Okay, let's have a quick recap. I just divide this expression by x plus 1, that is 3x square plus x minus 1. So it's 3x square, then I take it's 0 and it's plus 3x, so it's minus over here, minus 2x minus 1, so it's minus 2 minus 2x minus 2. So finally I'm getting 1 as a remainder. That means this expression, that is dividend is equal to divisor into quotient plus remainder. Okay, so here I am getting the remainder as 1. Okay, now let's see what is factor theorem. Factor theorem determines whether a polynomial qx is a factor of polynomial px or not. Here, if it is qx, it must be something else. Without performing the actual division. Let px be a polynomial, maybe it is linear, quadratic, cubic, or maybe nth degree. And pa is equal to 0. That means x is equal to a, or x minus a is a factor of px. Okay, or we can say conversely, if x minus a is a factor of px, then pa is equal to 0. I take one example. Suppose I have a polynomial px is equal to x square minus 5x plus 6. Now suppose I put the value of x as 2. So what p2 is, it's 2 square minus 5 into 2 plus 6. That is 4 minus 10 plus 6. That is 0. Okay, that means p2 is equal to 0. That means if I put x as 2, I get the value of this expression as 0. That means x is equal to 2, or we can say x minus 2 is a factor of this polynomial. Okay, similarly, suppose I put x as 3 in this case. Further, I get the value of this expression as 0. That means even x minus 3 will be a factor of this polynomial. So without performing actual division, we'll come to know about the factors of the given polynomial. So this is what the factor theorem. Okay. We'll be taking the applications of factor theorem or remainder theorem in the same session only. Now friends, let's discuss some basic algebraic identities before we proceed for problem solving session of factor theorem and remainder theorem. These identities you should learn, and these identities will be useful for you till you study algebra in your career. Okay, so let's discuss one by one, and definitely you have to memorize them. Now what x plus y whole square is? It's x square plus 2xy plus y square. X plus y whole square is the expansion of x plus y into x plus y. Okay. Similarly, x minus y whole square is x square minus 2xy plus y square. If it is plus over here, it will be plus over here. If it is minus over here, it is minus over here. Okay. So you can memorize them like this. Now x square minus y square is equal to x plus y into x minus y. Okay. Now if x plus a, x plus b format is there, and then it will be x square plus x into a plus b plus ab. Similarly, if it is x plus y plus z whole square, then it will be x square plus y square plus z square plus 2xy plus 2yz plus it's 2zx. Okay. Similarly, if it is x plus y whole cube, then it will be x cube plus y cube plus 3xy x plus y, or we can say x cube plus y cube plus 3x square y plus 3y square x. If it is x minus y whole cube, then it will be x cube minus y cube minus 3xy x minus y, or it will be x cube minus y cube minus 3x square y plus 3xy square. This last identity is very important, and there are applications based on these identities which are covered up in your course. We'll be taking this sort of identities in the same session. It is x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. Okay, so these are some basic identities which you have to learn. Okay. Now we have discussed an identity, that is x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2xz. What if the sign over here maybe 1 or 2, both the signs may be positive or negative. So you don't have to memorize each and every formula, you just have to convert the same formula to another. Okay, suppose I am having minus over here. So just try to understand. It's x square plus y square plus z square. Now the next step is 2 will be there. Now product of x and y, just see over here, it's x is positive and y is negative. So it will be minus 2xy. So I just put minus over here, it's minus 2xy. Now 2yz, it's minus y and z, so it will be minus 2yz. Similarly, z and x, both of them are positive, so I'll be getting 2xz is positive. Now suppose it's like this, then further x square plus y square plus z square will be as it is, since the square of minus z is also positive z square, the square of minus y is also positive y square. But in the remaining expression, we have to be clear about the sign of 2xy, 2yz and 2xz. So further I multiply x into minus y, so I'll be getting minus 2xy. Now x into minus z, it will be minus 2xz, and if minus y and minus z is there, then it will be converted to positive sign, so it's plus 2yz. Okay, so you just have to memorize one formula and the remaining can be converted easily. Okay, if it is minus x plus y minus z, then also the similar operations can be performed. Now you can give any values to x, y and z. Okay, now let's do some problems on factor theorem and remainder theorem. Okay, now this is the first question. We have to find the value of the polynomial 4 plus x cube minus x plus 2x square at x is equal to 0, 1 and minus 2. Let's write this polynomial as px. It's 4 plus x cube minus x plus 2x square. The very first step is just rewrite this polynomial in standard form. So it's x cube plus 2x square minus x plus 4. Now suppose I have to find out the value of this polynomial at x is equal to 0. That means I'll be putting the value of x as 0. So what it will be? It will be p0 is equal to 0 cube plus 2 into 0 square minus 0 plus 4. So finally we are getting 4. So value of polynomial when x is equal to 0 is 4. Now let's see when x is equal to 1, what happens? So let me put x is equal to 1. So it will be p1. That is 1 cube plus 2 into 1 square minus 1 plus 4. So it is 1 plus 2 minus 1 plus 4. So what I'll be getting is 6. That means value of the polynomial when x is equal to 1 is 6. Okay. Similarly, we solve for x is equal to minus 2. So it will be p minus 2. Now it is minus 2 whole cube plus 2 into minus 2 square minus of minus 2 plus 4. Friends, just put the value of x as it is. If it is negative, then just put the value of x in bracket. Okay. Now solve it. So minus 2 whole cube will be minus 8 plus 2 into minus 2 square will be 4. So it is minus 2 into 4. Minus of minus 2 will be plus 2 and then plus 4. So it's minus 8 plus 8 plus 2 plus 4. So what we are getting is 6. That means value of the polynomial when x is equal to minus 2 is 6. I hope you are clear. Let's take the next examples. Now in this question, find P0, P1 and P2 for each of the following polynomials. Same as in the previous question, you have to put the value of x as 0, 1 or 2 and you have to get the value of right hand side expression. Okay, so suppose I take maybe in this example I find out P0. That means I am putting x as 0. So it will be, this expression will be 0 plus 0 minus 5. So finally I am getting minus 5. So in this polynomial, P0 is minus 5. P1 and P2 you can calculate on your own. I just calculate P1 for this expression. It's P1, that means I am putting y as 1. So it's 9 into 1 cube plus 2 into 1 square plus 1 plus 7. So it's 9 plus 2 plus 1 plus 7. 9 plus 2, 11, 11 plus 1, 12, 12 plus 7, 19. Okay. For this expression or polynomial, I am putting z as 2. So I am calculating P2 for this polynomial. It was for this. Z is equal to 2. So it's 2 plus 1 and 2 minus 1. So it's 2 plus 1 is 3. 3 into 1 is 3. So for this expression, P2 will be 3. Okay. I calculate P0 for this also. So if it is P0, I have to put the value of t as 0. So it's 0 raised to 4, that is 0 plus 0 plus 1. So finally it is 1. So I hope you are clear. How do you find P0, P1, P2 for any of the polynomials? Okay. Now in this question, we have to verify whether the indicated numbers are zeros or roots of the polynomials corresponding to them or not. Okay, so we have already discussed factor theorem and remainder theorem. So suppose I take the question number 1, it is fx is equal to 3x plus 1 and I have to find out whether x is equal to minus 3 is a factor of this polynomial, or x is equal to minus 1 by 3 is 0 or root of this polynomial or not. Okay, so how can we do it? Just put the value of x as minus 1 by 3 and if we get 0, then x is equal to minus 1 by 3 is 0 of this polynomial, otherwise it is not. Okay, so let's do it. I have to check it at x is equal to 1 minus 1 by 3. So I calculate f minus 1 by 3. It is 3 into minus 1 by 3 plus 1. Okay, so it's minus 1 plus 1. So we are getting 0. That means minus 1 by 3 is the root or 0 of this polynomial. Okay. Now similarly in this question, we have to check at x is equal to 1 and minus 1 both. So first of all, I take x is equal to 1. So f1 is equal to 1 square minus 1, that is 0. That means 1 is factor, or we can say root or 0 of this polynomial. Okay. I'm sorry, x minus 1 is a factor, or we can say 1 is 0 or root of this polynomial. Now suppose I check x is equal to minus 1, then it is minus 1 whole square, minus 1. Further it is 1 square minus 1, or we can say 1 minus 1, it is 0. That means even minus 1 is 0 or root of this polynomial. Okay. Now let's do this. We have to check at x is equal to 2 by root 3 and minus 2 by root 3. So it is g 2 by root 3 is 3 into, we put the value of x as 2 by root 3 whole square minus 2. So what we'll be getting is 3 into 4 by 3 minus 2. So we are getting 2. That means we are not getting 0. That means 2 by root 3 is not 0 or root of this polynomial. Okay, I hope you are clear. Let's put minus 2 by root 3. So g minus 2 by root 3 is equal to 3 into minus 2 by root 3 whole square minus 2. Now square of negative term will be positive, so it's 3 into further 4 by 3 minus 2. So still we are getting 2. That means we are not getting 0. That means even minus 2 by root 3 is not the factor of this polynomial. Okay. Now in this question we have to check whether 1, 2 or 3 are zeros of this polynomial or not. So let's first of all find P1. It's 1 cube minus 6 into 1 square plus 11 into 1 minus 6. So it's 1 minus 6 plus 11 minus 6. So it is 12 minus 12, 0. That means if we put x is equal to 1, we are getting 0. That means 1 is the root, or we can say 0 of this polynomial. Now similarly we check for 2. So P2 is equal to 2 cube minus 6 into 2 square plus 11 into 2 minus 6. So it is 8 minus 2 square is 4. 4 into 6, 24 plus 11 into 2, 22 minus 6. So it is 22 plus 8, 30, and minus 24 minus 6 is minus 30. So still we are getting 0. That means even 2 is a factor of this polynomial. Similarly we can check for 3. So P3 is equal to 3 cube minus 6 into 3 square plus 11 into 3 minus 6. So 3 cube is 27 minus 3 3s are 9. That means 3 square is 9 into 6, 54 plus 33 minus 6. So it is 27 plus 33, that is 60, minus 54 minus 6 minus 60. So still we are getting 0. That means even 3 is a root or 0 of this polynomial. That means 1, 2 and 3, all of them are zeros of the polynomial. Okay, so I hope you are clear. Now let's see this question. X is equal to 4 by 5. So we have to calculate f 4 by 5. So f 4 by 5 is, put the value of x as 4 by 5 minus pi. So it's 4 minus pi. That is not equal to 0. That means if we put x is equal to 4 by 5, we are not getting 0. That means 4 by 5 is not a 0 of this polynomial. Okay. Similarly in this case, let's calculate f0. So it's 0 square, that means 0. That means 0 is the root, or we can say 0 of this polynomial. Okay. In this case, x is equal to minus m by l. Just put the value of x as minus m by l. So it's l into minus m by l plus m. So what we are getting is minus m plus m, that is 0. So we are getting 0 if we put minus m by l instead of x. That means minus m by l is 0 of this polynomial. Okay. Now let's see this. In this case we have to calculate the value of this polynomial when x is equal to 1 by 2. So it's f 1 by 2 is 2 into 1 by 2 plus 1. So we are getting 2. That means this number, that is half, is not the 0 or root of this polynomial, since we are not getting 0 in this case if we put x is equal to 1 by 2. Okay, so we have discussed a good number of questions based on factor theorem. Friends, we'll be taking more problems and concepts in the next session. Till then, do revise this session, and let's see what happens in the next session. Bye-bye.